Hello everyone, welcome to this channel, and today I'm going to discuss about the mechanism of action of anticholinesterases. So what are anticholinesterases? These are the drugs which basically act with the enzyme acetylcholinesterase in the same way acetylcholine does. So they are basically the esters of carbamic acid or the derivatives of phosphoric acid, and there are certain anticholinesterases which are not carbamates, but the mechanism is like that of carbamates. So first of all, we will classify. So anticholinesterases can be divided into two types, reversible and irreversible. Among the irreversible anticholinesterases, there are carbamates like propoxar, which is also known as Vagon, which is an insecticide, and organophosphates like malathion, diflos, etc., which are also insecticides, and tabun, which is a war gas. And in case of reversible, there are carbamates like neostigmine, physostigmine, pyridostigmine, rivastigmine, and non-carbamates like donepezil, adrofonium, galantamine, tacrin, etc. So now this is the structure of carbamate. So if the R1 tertiary is tertiary amino nitrogen, that is non-polar nitrogen, it is lipid soluble. Example is physostigmine. And if R1 is quaternary and plus, it is lipid insoluble. Example is neostigmine. So the thing is that the lipid soluble drugs can readily cross the blood brain barrier. So physostigmine is useful in the disorders related to central nervous system, and neostigmine, as it is lipid insoluble, water soluble, it is basically a peripherally acting drug. Now organophosphates, this is the structure of organophosphates, and these are highly lipid soluble compounds, and there is an exception of that is ecothiophat, which is organophosphate but which is water soluble. So now the actual mechanism. So the reaction of anticholinesterases with the enzyme is same as that of the acetylcholine, but different anticholinesterases form different compounds, and depending upon that the reaction time may be prolonged. The carbamates basically carbamylate the enzyme in the asteretic site, and phosphates causes phosphorylation of the asteretic site. So this is the enzyme, and this is the asteretic site, this is the anionic site. First of all, we will discuss about the reaction with water, how it reacts with the water. So activated enzyme reacts with water extremely rapidly, and the site of reaction, that is the asteretic site, that means this site is freed in a fraction of millisecond. So this is the reaction of the acetylcholine with the enzyme. So basically acetylcholine acts in the asteretic site. This is the complex between the enzyme and acetylcholine, and this is the acetylated enzyme. Here S here is the serine residue, his means histidine amino acid, and glue is glutamic acid. So this is the freed enzyme with the acetic acid. Now we will discuss about the reaction with the carbamylated enzyme. So the carbamylated enzyme reacts slowly, and non-carbamates such as adrofonium attached to the, and that is these are reversible. The site of anionic site, that is this site, and it does not form any covalent bond, rather it forms hydrogen bond which is very weak, and the hydrolysis of the inhibitor does not occur here, and only its diffusion occurs. So the T half of reactivation of the carbamylated enzyme is less than the synthesis of fresh enzyme protein, and the T half is between half to 6 hours. The T half here is between half to 6 hours. So as you can see, the carbamylated enzyme, there is slow reaction, and the formation of substituted carbamic acid plus the free enzyme. So basically the synthesis of the enzyme protein is time is more than that of the reactivation of the enzyme. So it is reversible inhibition. Now in case of phosphorylated enzyme, it reacts extremely slowly or not at all. So the organophosphate attached to the asteretic site, that is this site, and forms strong covalent bonds which are unbreakable, and the phosphorylated enzyme may also undergo aging by the loss of one of the alkyl groups, or either R1 or R2, and it may also become totally resistant to hydrolysis, and which forms which causes irreversible inhibition of the enzyme. So this is the mechanism of anticholinesterases. And here I am ending my today's discussion. See you in my next video, and if you guys like my videos, please subscribe the channel. Thanks for watching.